So part 17 here on page 22, this is the last of the parts for this unit. We're going to be talking about VSEPR today, V-S-E-P-R, okay, pronounced VSEPR just as an acronym there. We're going to be working on how we think about these things in 3D space. We use the Lewis structures first, okay, but today's target is going to be you can correctly draw the VSEPR for any structure that we need to, okay. So over here on the right, looking at some definitions and kind of some basics about VSEPR. So shapes of the covalent molecules, like we were drawing with Lewis structures, can actually be determined because we have a pretty good reference as to what they look like in 3D space. Because we know the electrons, since they're both negatively charged, they repel each other. Think about if you take two magnets, if you have the opposite poles, they attract. If you have two negatively charged, they push each other away. Because of that, we call this theory valence shell electron pair repulsion theory, okay? So quite literally, valence shell, the electrons in the outer shell, okay? We're talking about electrons, so it says electrons. Electrons exist in pairs, like we were practicing with Lewis structures. So valence shell electron pair repulsion because they repel each other, okay? If you take the VSEPR from here, that's how we get VSEPR, okay? Now, we're going to be using a table of VSEPR theory to help us, which is on the next page that we'll talk about in a second. What you should know, though, is a non-bonding pair, meaning a lone pair, just two dots on the atom, is going to repel more strongly than if you have a bond, okay? So because we know this, we can actually figure out what these look like for shapes, okay? Now, if we think about this last note here, we'll get to in a second, but if we think about the steps to get to drawing the shapes and using VSEPR, you first draw the Lewis structure, okay? That's what we just practiced in part 16. Then you count the electron pairs around them, and we use the table, okay, which is where we're going to get the way that it minimizes repulsion, okay? And then the table will tell us the shape, the name, the bond angles, okay, that we're going to work with, all right? Now, what we're looking at next is that table. So if you flip the page over here, that table that shows us what's happening here is right here, okay? Now, as we look at this table, this first column we'll practice in a couple minutes, but this first column isn't as useful. These next two are really useful. So how many bonds are there around the middle thing? How many lone pairs are on the middle? What angles will they take? What's the geometry of the electron pairs and atoms called? That's how we refer to them. So referring to something as having a tetrahedral orientation or something like that. 3D shape is drawn out for you, okay, and it gives you an example of each one. Okay? Let's get started. It's the only way it's going to make sense is if we actually do some of these and then use the table later, but we're going to start by reviewing our VSEPR theory from the last part, okay? PCl6 with the -1 charge, if you remember, was actually one of them that we did talk about last time in part 16, but we'll do it again here. So our electron count, okay? What we're going to do is we're going to add that up first. If you have that little cheat sheet table handy in front of you from part 16, that'd be helpful, okay? So P has 5, there are 6 chlorines, 7. It's -1, so you do the opposite, add 1, we get 48, okay? Now, I start thinking, okay, what's going to go in the middle? Well, there's 1 P and 6 Cl, so hopefully that's pretty obvious. So I'm going to put this 1 P by itself in the middle. How many bonds is the thing on the outside? So the chlorines want, well, they each only want 1, so we're going to draw on that 1 line. How many dots will they get then? Well, that's 2 electrons. They need to have 8 near them. That means they need 6 more. They come in pairs, so we draw 6 in pairs. Sorry, that's 2 dots over there. Count them all up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. Matches my total. Done. Okay, that's review of Lewis structures. Okay, nothing new there. The new part comes into play here. For VSEPR, you only focus on the middle. So I look at the P. I say, okay, how many bonds does it have around it? Okay, but the weird thing would be if these are double bonds, they count as like 1 bond. So it's almost like I ask myself how many things are bound to it. So there are 6 chlorines. So 6 things bound to it, okay? And then, so 6 things bound to it, and then are there any pairs of dots on the P? You say no, because there's no dots on there, okay? So that's where we come to these 2 columns here. I'm going to highlight the 2 columns we're really going to use, because these are the ones that we're going to come back to over and over again, okay? Like the first column doesn't really matter. All it did was say 2 plus 0 is 2, 3 plus 0 is 3, 2 plus 1 is 3, 4 plus 0 is 4, 3 plus 1 is 4, and so forth, okay? So we don't really care about that first column. But I just found out that my PCl6, the P has 6 things bound to it, no lone pairs. So I'm looking at a 6 for this column because it's so how many bonds, okay? 6. How many pairs of dots on there? 0, okay? So if I get 6, 0, I end up here, okay? Which means that if I asked you what the bond angles were, you would say 90 because it says predict the bond angles. So 90 degrees. The central atom geometry, okay, we come here, central atom geometry is called octahedral, but what's really important is that you draw it. So what these drawings are showing you is that they're basically showing the atoms. So the darker dot in the middle is the central atom, in our case that's a P. The white circles are the CLs that go around it. But what's interesting about these dark lines and these dashed lines, this is where students that are really good at art have an easier time at seeing this, but these dark lines mean that they're coming out towards you if you imagine having this 3D shape in front of you, and the dashed lines are going away from you. So to try to help with that, I pulled this one up. If you look at this, this is the same structure here. Imagine this in 3D. If you had this right in front of you, these two right here would be coming out towards you, okay? And these two are kind of going away from you, is what we're trying to show, okay? We do that by showing a darker line for these guys that are coming out at you, and these dashed lines for the ones in the back, okay? But all I really need you to do is draw that same structure that we see here, okay? One of the should do activities is going to get you thinking about these 3D shapes even more, okay? But I just need you to draw this for me. You can draw it exactly as is by leaving the white circles and then that darker middle circle, or you can rewrite it. I tend to write it with the CLs and the Ps because that reminds me what I'm working with here. So if I show you that, we have in the middle the P. I've got, if I look at this picture, coming straight up with the normal line is a CL, coming straight down is a CL, or a white circle. You can draw an empty circle there, that's fine. And then I've got dash going back. I draw my dashes ways. They draw them like straight across. It doesn't really matter how you dash them, okay? I've got a CL on either side. Then I've got a darker line coming forward, okay? So I'm kind of making a really dark line here, okay? I'm putting my CLs there. So that tells me I have my 6 CLs. So what these are showing with this dash and these darker lines is that it's in the exact same space. And if you're looking at it eye level, these CLs would come at you. These CLs would go back away from you, okay? Let's try the next one, ICL3. We always start with our electron count just like normal. So I've got 7 for all of these. 7 for the I. There are 3 chlorines on 7. You get 28. What goes in the middle? 1 I, 3 CLs. Should be pretty obvious it's going to be an I. How many bonds does each CL on the outside want? Just 1. How many dots does it need then? Well, it has 2. So to get to 8, I need 6. So I count them, right, because I have the right number of dots for each CL. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26. It's 24. Hold on. Try again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? I have 24. I need 28. So that means I have 4 more dots I need to do. Okay? Now I'm going to put them on the middle, and here's why. All of the CLs already have the right number of dots. We do not want to add any more dots to the CL. If we did, then that means they don't have 8, and everything's looking for that octet, the octet rule of 8. So the only place they can go is on the middle. Okay, so they're both going to go on the I. Now I count them again, I'm going to get 28, which means I'm good to go because that count matches. And that's why we always check our counts, because sometimes there'll be extras that have to go in the middle. For VSEPR, for this table, I focus on the middle, which is my I. My I has how many things bound to it? Well, 1, 2, 3. 3 chlorines, okay? How many pairs of dots does it have on the I? 1, 2 pairs of dots, 2 pairs. So I need 3 things bound, 2 pairs. So I come to this table, I come down till I get to 3, 2. So this is the one I want. So bond angles are about 90. It's called T-shaped. It's the geometry of atoms that we refer to. You can say it's trigonal plane or bipyramidal, specifically T-shaped. Okay, that's how you refer to that. Because all of these say trigonal bipyramidal. And then I draw that structure. So again, you can copy it exactly how it is, or you can relabel them like I do. I just like to show what the heck is actually happening here by putting my I's and my CLs. Notice on the side, I've got really dark line coming at me. I've got a pair of electrons. Then I've also, going away from me, also have a pair of electrons, because the I has these electrons that take up their own space too. Okay? It looks like this one's similar, okay, right here. The only difference is that we basically have this, but this, and on the side here, this is a pair of dots, and so is this. So imagine there's something straight up and down, okay, something straight off to the side, and then off to one side, there's two pairs of dots, kind of one coming near you, one coming away from you. All right, BRF5. Start with our electron count, as always. 7 for the BR, 5 Fs, each one has 7. Add those all up, get 42. What goes in the middle? 1 BR, 5 Fs. The BR. How many how many bonds do the Fs want on the outside? Just one. How many dots do they need then? Well, they need 6 more to get them to 8. Add them all up, okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. I need 42, okay? So that means I have to put 2 more on the middle. Now I have 42. How many things are bound to the BR? Okay, that would be 5 things because there's 5 Fs. So 5. How many pairs of dots are on the BR? Just one. Okay, there's one pair there. So I come down to 5, 1, which looks like this. Okay. Now I'm going to draw it. So if I have here, I've got an F coming straight up. There's my BR. Coming straight down, I have a pair of electrons. Then I've got going back away from me, that's dashed. And coming out towards me, that's this darker wedge is basically how I draw it. As long as you draw a darker line coming out, it tells me that you understand that it's 3D here on a 2D piece of paper. We have an F, an F, an F, and an F. Okay, there's 5 Fs and a pair of electrons. Right? So that one looks very similar to this top one up here. It's just on the bottom there's a pair of electrons. So think about this one again. On the bottom though, we've got a pair of dots. Okay, so a pair of electrons kind of occupying their own space. Okay. All right, so I'm going to need you to go ahead and try this. So go ahead and try these practice problems, and then we're going to go ahead, check your work, and then try a mastery check on this. And that's our last topic here with us.